Hello everyone. Now we will see the discussion of types of orbits from the Earth surface. In general, we can divide uh, uh, the orbits into which the satellites can be placed into four types. The first type is low Earth orbit, that is from 160 to 2000 kilometers. Why only the satellites can be placed in the orbits from above 160 kilometers is simply because below 160 kilometers there will be atmospheric drag, and because of this the satellites can't be placed in the orbits. Even if they are placed, they have to expend a lot of amount of fuel to adjust to the velocity, so that it can again come back to the original orbital position. So in the same way, you have these medium Earth orbits from the 2000 to 35,786 kilometers. Now, the third type of orbit is geostationary orbit. It is a very peculiar orbit. We will discuss why it is peculiar. The last one is high Earth orbits. Now, before moving to this discussion, we will see the discussion on the velocity of the satellites for for a satellite to be placed in an orbit. Now, let us see. As we have seen the orbital velocity V naught, one minute. See this, the orbital velocity V naught is generally given by this formula. That means the velocity is inversely proportional to the radius. So that means, let us suppose you have to place a satellite. See this one. Let us suppose this is Earth, considered to be this Earth. Okay, excuse me. Okay, consider this to be Earth. Now let us suppose you wanted to place a satellite from Earth to, let us suppose from Earth to here. So that means, let us suppose the distance is some, this orbit is low Earth orbit, let us suppose this being some 300 kilometers distance. Okay. So now that means you have to find the satellite to place it at a distance of 300 kilometers. That means orbital velocity should be that you can find out the orbital velocity from that formula. So what happens here is, so for a satellite, for it to rotate in this orbit at 300 kilometers, it has to revolve at a large amount of velocities. Why? Because is, let us suppose you want to place a satellite on a bigger orbit. Let us suppose this being the, this is the orbit. 1 minute. Let us suppose this being the orbit. Now let us suppose you want to place the satellite from Earth to this orbit. So obviously the distance you have to travel is very high. That means the R value is very high. That means if the R value is very high, what happens to the orbital velocity? The orbital velocity decreases, doesn't it? Right? So that means the important point here is, the important point you need to understand is, a satellite, for it to revolve in the lower orbits, it has to travel at high velocities, whereas for a satellite to travel at higher orbits, it has to travel with lower velocities. So the satellites which travel in the lowest orbits, they travel at higher velocities. Means what happens means, so satellite traveling at higher velocity means it will rotate the Earth very fastly. In general, a satellite, for instance, you must have heard this NASA's ISS, that means International Space Station. International Space Station. This International Space Station exists in low Earth orbit. Low Earth orbit. It has to travel with very large velocities. For instance, this ISS, due to its higher velocities, it rotates around the Earth for every 90 minutes. Okay, but if you go to higher orbits, it will take a large amount of time for you. So with this idea, now we can start defining this orbit, the third type of orbit, that is geostationary orbit. See, this is geostationary orbit. So see what why the geostationary orbit? It is the geostationary orbit is it is at a distance of 35,786 kilometers. So it is 35,786 kilometers. So what happens at this range is, so if you keep the satellite at this radius. So if you find the orbital velocity, what happens is this orbital velocity, with this orbital velocity, the satellite will take exactly the same time period of the rotation of the Earth. That means 23 hours, 56 minutes, 4 seconds. So that means what happens here is the satellite will be in sync with the Earth. So that means let us suppose what happens is you want let us the satellite is here. Let us the satellite is here, and this let us consider to this to be Earth. What happens here is the satellite for a person staying at a particular place, he always sees this satellite as stationary. Okay, why? Because both are traveling with the same orbital velocities and same orbital time periods. So that's why for a person, a satellite in a stationary orbit always appears to be stationary. That's why the name geostationary orbit is given to that picture. Now, with this function, we can keep the satellites at different orbits based on our usefulness of the satellite. Let us suppose I want to have a telecommunication satellite. What is the functioning of a telecommunication satellite? The telecommunication satellite. Let us suppose here this on this part of India, you have to give continuous telecommunication network. That means the satellite, whichever is staying in this geostationary orbit, should be covering the same place. So, but if a satellite is placed in the low Earth orbit, what happens is it rotates for every 90 minutes, right? So that means it cannot stay on the above the surface of the Earth always. So it cannot continuously give coverage for the telecommunication. So for a constant signal, for functions of constant signal, the satellites are placed in a geostationary orbit. But if the functions of a satellite are such that weather patterns, let us suppose you want to find out the global weather patterns. So that means the satellites can be placed in lower Earth orbits. Why? Because low Earth orbits, it rotates for every 90 minutes, so it can cover the entire globe. So with this idea, the orbits have been distinguished. So now we will see the different types of orbits. Okay. So now see this. What is geostationary orbit? So a geostationary orbit So a geostationary orbit, often referred to as GEO, circles the Earth above the equator from west to east. Okay, so that means geostationary orbit it always lies above the plane of the equator. So this is the plane of the equator. The geostationary orbit, the satellite should continuously lie in the plane of the equator, and it should also rotate from west to east. That means you know that Earth rotates from west to east. So at a height of 36,000 kilometers, it is the same as 35,706 kilometers. So so see the speed. The speed in a geostationary orbit, it is about 3 kilometers per second. Whereas for a satellite rotating in low Earth orbit, it is like 7.8 kilometers per second. Okay. So that's what I am saying. Geostationary orbits, as they continuously cover over a large portion Earth, this makes it ideal for telecommunications, right? I told you know. So, or for monitoring continent-wide weather patterns. Let us suppose you don't want global weather patterns, but you want to find the weather patterns or the precipitational changes occurring only across India. Then also you can use geostationary satellites. Now, the another advantage of geostationary satellite is, see this one, it also decreases cost as ground stations do not need to track launcher. What this specifically means is, if a satellite is placed in the low Earth orbit, what happens is, as it rotates very fast, whatever the ground station tracker, so should continuously track the satellite to continuously receive the signals. So it increases the cost, whereas the geostationary satellite is always appears to be relatively static from the same point on the Earth. So there is no extra cost for tracking the satellite. So another advantage of geostationary satellites is, see this one, a constellation of three equally spaced satellites can provide full coverage of the Earth except for the polar regions. So three equally spaced satellites, that means, let us suppose, um, what this specifically means is, see here, let us suppose you take Earth, okay. Now the funda here is, what he is stating is, let us suppose a satellite, this is a geostationary satellite, okay. Let us suppose this is geostationary satellite. Let us suppose you have placed one satellite here, you have placed second satellite here, you have placed third satellite here, each at 120 degrees angle, okay. So those three satellites can cover entire globe, okay. So this is the functioning or the advantage of the geostationary satellites. Okay, I hope you got this geostationary orbits, okay. Now, the same geostationary orbit, the same concept, there is another orbit known as a geosynchronous orbit. The basic difference between this geosynchronous orbit and geostationary orbit is, see, both orbits lies at the 6,000 kilometers, but geostationary is always above the equator, but geosynchronous, it is at an angle of inclination from the Earth. See this diagram, it is at an inclination, but the distance is the same, 6,000 kilometers. These kinds of orbits are known as geosynchronous orbits, okay. These kinds of known as geosynchronous orbits. Now see the low earth orbits, as we already discussed this, what are low earth orbits. So a low earth orbit is normally at an altitude of less than 1,000 kilometers and could be, as we have said. So see, the satellites in this travel around 7.8 kilometers per second. That's what I'm saying. More velocity in the lower speed. At this satellite, I have identified 90 minutes close to the Earth. Okay. So which satellites are placed in low Earth orbits? We see this one. These orbits are used for remote sensing. Why? Because remote sensing means continuously you need to track the entire globe. So that's why this one, in the same way, military purposes and human space flight, uh, all these purposes, low Earth orbits are the sea. This is a very important question. The International Space Station is in the low Earth orbit. Why it is low Earth orbit means, in general, what happens is, this ISIS, if there are any repairs in the satellites placed in higher orbits, it usually lies in the lower Earth orbits, and repairs those satellites which are in need of maintenance. Okay. Next thing which is important is polar orbits. See, polar orbits. So polar orbits are nothing but they travel from pole to pole. See, this one passes from Earth's polar region from north to south. Okay. Another thing is why it is called polar. So see this one. The satellites in polar orbit look down on the Earth's entire surface and can pass over the north and south pole several times a day. So they travel from pole to pole. So where are the polar orbits are used for? They are used for reconnaissance, Earth observation. Okay. So this is the polar orbit. Now see the another type, sun synchronous orbits. So what are sun synchronous orbits? These are nothing but polar orbits which are synchronous with the one. What is synchronous with the sun means? That means these orbits rotate in such a way that the sun illumination always falls on the place where the satellite is there. So that means what happens is, it becomes very easy for the satellite to take images in the sun illumination. Those kinds of orbits are known as sun synchronous orbit. So, these orbits are used for Earth observation. Why Earth observation? You need to take a lot of images. So that's why you have to place the orbit satellites in the sun synchronous orbits. So solar study, all these are placed in the sun synchronous. So see, this point is important. What is this point is? Surface is always illuminated by the sun at the same angle. So if the sun is at the same angle with the satellite, then that is orbit is sun synchronous orbit. So these are the different types of orbits, and based on the requirement of the functioning of the satellite, it is placed in different orbits. I hope you got a sense of the kinds of orbits. Okay.